Total distance is 1073. True airspeed is 170. Headwind is 20 knots going outbound. What is the time and distance to CP? And the next part is says fuel on board is sufficient for flight time. Calculate time and distance to PNR. Okay. Calculate time and distance to PNR. So let's start with critical point first. So whenever we do critical point, like always, I will draw this A to B. We have critical point somewhere here. Now as we go from A to B or A to critical point, okay, what are we experiencing? What are the winds that we experiencing? So they are coming from headwind, that is in front of you. At what speed? At the speed of 20 knots. At the speed of 20 knots. So going outbound, when your aircraft is flying outbound, okay, when your aircraft is flying outbound, it is going to face a headwind of 20 knots. When that same aircraft experiences an engine failure or anything else at critical point, and it decides to come back to point A, okay, it decides to come back to point A, that is, it reverses its track direction and comes back to point A, it will experience what? It will experience a tailwind. It will experience a tailwind of same 20 knots. So going outbound, it is headwind of 20 knots. Coming inbound towards departure airport, the same wind will function as a tailwind. Now let's draw a table like we always do for critical point. So always from two column, the track column, the task column, the winds column, and the ground speed. Okay. Now first we will be going outbound. So ground speed outbound from A to CP, ground speed outbound from CP to B, and ground speed homebound, ground speed homebound from CP to A. So let's start. Going from A to CP, your track direction is going from A to CP, the track direction is irrelevant. So track direction is not given. We have been given TAS and headwind. So that is enough. Actually, we don't need track. We need track when they give us wind velocity. And that values we put in the CX3 to get ground speed. But now here they have directly given us a simple wind component, that is headwind. So we can add or subtract that to TAS and get a ground speed. So TAS is 170 in all cases. 170, 170, 170. Now wind velocity going outbound is a 20 knot headwind. So minus 20 I am writing for headwind. And then when you come inbound, that is homebound from CP to A, that same wind will become a tailwind. So I will write plus 20 here. I will write plus 20 here. So 170 minus 20 is 150, 150 and 190. That is your ground speed. So with this table complete, now let's go to your formula. Critical point distance is dH divided by O plus H. So D is how much? 1073. Homebound speed is 190. And outbound speed, that is outbound speed from CP to B, is 150. So 1073 into 190 is 1073 into 190 is 203870 divided by 190 plus 50, 150, 340. So your distance to critical point is 203870 divides 340. So that is equivalent 599.6 or approximately equal to 600 nautical miles. Approximately 600 nautical miles. Okay. Time to CP, very simple. Distance to CP divided by ground speed outbound from A to CP. You are going outbound, right? We are calculating time to CP, towards CP. So you are going towards CP only in one case, A to CP. So 600 divide by 150, 4 hours. 4 hours. So simple. If you want the help of a diagram, draw the diagram to understand better. Table. Now everywhere for critical point you have to draw the same table, the same 5 columns, same 3 rows, and fill the data that is given in the question properly. Use CX3 where applicable. If track is given and wind component is given with the wind direction and wind speed, so in that case you will have to use CX3. But when they have directly given a headwind or a tailwind flying outbound, okay, so you can just add or subtract and get your ground speed directly. So this saves time actually. And then put the formula and then put the values in that, and that's it. Use your calculator properly, put the values carefully in it, and also the values here are big values, so you have to be very careful that you don't miss any digit in between. Okay, so that can give you a definition for flight time. Okay, that means the fuel that you are carrying on board, that will be all that fuel will be used for your flight time. So going from A to B, the time will be how much? Distance divided by speed. So 1073 divided by outbound speed. So outbound speed is how much? It is 150 knots going from A towards CP or A towards B. So it is how much? 150 knots. So your flight time is 1073 divided by 150. So that is equal to 7 hours and 9 minutes. So that is equal to 7 hours and 9 minutes. So your total flight time is 7 hours 9 minutes. Okay. So fuel on board is just sufficient for your flight time. So that means in the calculation of distance to PNR, what do we have? We have endurance. And what is endurance? The flight fuel time. So with the amount of flight fuel available to you, how much time will you stay up in the air? So that is your flight fuel. Now in this case they say that the endurance is equal to your flight time. In this question they have given the fuel on board that you are carrying is just sufficient for flight time. So that means the fuel that is available to you will get finished up. Okay, it will all finish when you reach your destination. There is no reserve fuel, there is no alternate fuel, there is no extra fuel in this aircraft. Okay, the fuel that pilot is carrying in this aircraft is only that much required for conducting flight from A to B. So indirectly they are saying that your flight time is equal to your endurance, okay, which is equal to 7 hours and 9 minutes, is equal to 7 hours and 9 minutes. So that they have clearly mentioned fuel on board, whatever fuel is there is only available for flight time. Okay, sufficient for flight time. So in that case, let's rewrite the formula. Distance to PNR is endurance into outbound speed into homebound divided by outbound plus homebound. So 7.1 or 7.1 into outbound speed is 150, homebound speed is 190, 150 plus 190. So outbound speed is equal to 150. Okay. So 7.1 into 150 into 19 is equal to 20 2350 divided by 150 plus 90 is equal to 340. So your distance to PNR is how much? 202350 divided by 340, which is equal to 595 nautical mile, which is equal to 595 nautical mile. If you make this 7.1 into 7 hour 9 minute, you will get more accurate answer, which is 7 hour 9 minute into 150 into 190, which is 203775 divided by 340. So that is equal to 599.3 nautical miles. Okay, so this is the distance to PNR, 595 or 599, not much difference with respect to the theoretical question, numerical sum for exam. Time to PNR is distance to PNR divided by ground speed outbound A to B. So 599 divided by 150, so which is equal to approximately 4 hours. Approximately 4 hours. Okay, so this is how you find the answer. Now this numerical sum that we have done now is a very important property of point of no return, that if the fuel that you are carrying on board is just sufficient for conducting that flight, okay, is just sufficient for conducting that flight, in that case the flight time, which is the time that you will fly for going from A to B, that flight time will be equal to the fuel that you are carrying. So if flight time to go from Mumbai to Delhi is, let's say, 10 hours, so you will carry that much amount of fuel on board, which will give you an endurance of 10 hours. Okay, only that much amount of fuel, which will also give you an endurance of 10 hours. You won't carry extra reserve, alternate, or any of that fuel. So if that is the case, if the fuel on board is only available for conducting the flight and there is no extra fuel, so that in that case the fuel on board will be equal to your flight time. Okay, and in that case your critical point distance, which was how much? 600 nautical mile. Time was for critical time also 4 hours. Same values are for PNR, 4 hours and 599. So when such is the case, when fuel on board is equal to your flight time, okay, your distance to critical point will be equal to distance to your PNR. Time to critical point will be equal to your time to CP. Okay, all two of them will be equal. So remember this property, and this is the proof of that property. Let's go to next question, question 25. Flight is from A to B, total distance is given, track is given, task normal and task reduced. Task normal means all engines are working, and task reduced means engine failure has happened. Winds are given, fuel on board is given, reserve fuel is given, K means 12,000, 2K means 2000. Fuel consumption at normal, so that means when all engines are working, your fuel consumption rate is 1200. When engine failure has happened, fuel consumption has become 1000. What is the time and distance to critical point? Time and distance to PNR when all engines are working, time and distance to PNR when engine failure has happened, and calculate still air range. Okay, so big sum. So let's start with critical point. So like always, we will calculate critical point table. So ground speed outbound from A to CP, ground speed outbound from CP CP to B, and ground speed homebound from CP to A. So there is A, there is CP, there is B. Your plane is going to go from A to CP. At critical point where there is an engine failure, the pilot makes a decision to make a U-turn and come back towards point A. Come back towards point A. Okay. Next, so let's put the values, appropriate values. When going outbound, your track will be 135. So your track will be 135, 135. Coming inbound, your track will become the reciprocal of 135, which is 315. True airspeed. Now there are two types of true airspeed is given. The first, when all engines are working. So for that is 250. So when you go from A towards critical point, you assume that your engines are working. Engines okay. At critical point, there is an engine failure. Engine has failed. Okay. So from A to CP, the task will be normal task, which is 250. At CP, the engine has failed. So anything starting from critical point, going from critical point to point B, or coming back from critical point to point A, you will be flying at a reduced task due to engine failure. So reduced task is 215. So going from critical point to point B is 215. Critical point to point A is again 215. Wind velocity is how much? In all cases 090 at 30. 09030, 09030, 090 at 30. Now let's put these values in CX3 and calculate. So go to wind speed, wind correction, and put the values. So first, let's start with the first. We have a task of 250, track of 135, wind speed of 30 knots at 90 degree. So your ground speed will be equal to, in that case, 250, 135, 30, 90, 227.8. Let's take it to 28. Now let's go to next row. Airspeed has decreased and become 215. True course has stayed the same, 30, 90. So your new ground speed is 192.9er. So make it 193. Last, true airspeed is 215. Course is 315. In that case, your ground speed will be, when coming back from CP to A, 235.16. 235.16, just let it be 235. Now distance to CP formula, DH O plus H. So total distance is how much? 1250. Homebound speed 235. Divide by 235 plus outbound speed 193. So 1250 into 235 is 293,750 divided by 428. 293,750 divided by 428 is equal to 686 nautical miles. So distance to critical point will be equal to 686 nautical mile. Time to critical point will be distance to critical point divided by ground speed outbound A to CP. So distance 686 divided by 228. So time to CP is equal to 3 hours is equal to 3 hours. Okay, 3 hours. So make sure you get this sum right. It is equal to 3 hours. Very simple. Only the thing different is this. You will be using a reduced task at critical point onwards you will be using reduced tasks. Okay, because in the question they have given two types of tasks. That means there is an engine failure at critical point. Now let's go to time and distance to PNR. So let's calculate distance to PNR. All engines working. So let's draw our table from 2. Okay, next track, task, wind, ground speed. So going outbound from A to PNR, normal speed. Coming homebound from PNR to A, normal speed. So going outbound, track 135. Coming inbound, track 315. Coming inbound track is 315. So normal task is how much? 250. So we will use 50 knots. So we have to calculate distance to PNR for normal conditions when all engines are operating. Outbound A to PNR, PNR to A, track outbound 135, inbound 315, task 250, 250, winds 090 at 30, and ground speed 228 and 270 that we calculated from CX3. Let's calculate endurance, which is fuel on board minus reserve divided by fuel consumption at normal rate, which is your when all engines operating rate. So 10,000 divided by 1200. So endurance will be equal to how many hours? It will be equal to 10,000 divided by 1200, 8 hours 20 minutes. 8 hour 20 minutes. So let's use the formula now. Distance to PNR equals to endurance into O into H divided by O plus H. So 8.8 hours 20 minutes into outbound 228 270 divided by 228 plus 270. Distance to PNR will be equal to 8 hours 20 minutes into 228 into 270 divided by, so that is 51300. 498 is 1030 nautical miles. 1030 nautical miles. Time to PNR will be equal to distance divided by outbound speed of 228, which is equals to 4 hours 4 hours 31 minutes. So in your exam you will select the option which is closest to both of them. So very simple, just draw the table, find endurance, substitute the value. So distance is 1030 and time to PNR is 4 hours 31 minutes. Now let's go to the next part of the question. We have to let's calculate still air range. Very simple, we will calculate that. Still air range is equal to fuel on board divided by fuel consumption at normal rate into TAS. So fuel on board is how much? 12,000. Fuel consumption at normal rate is 1,200. TAS at normal rate is 250. So it will be 2,500 nautical miles. Still air range we have found out 2500 nautical miles. Fuel on board, fuel consumption normal, task normal, substitute and get the value. Now last point, calculate time and distance to PNR considering that engines have failed. So let's draw the table from and to, your track, your task, your winds and your ground speed. Okay. Now ground speed outbound from A to PNR and ground speed homebound from PNR back to A. Outbound is 135, homebound is 315, outbound speed is 250, homebound speed is 215. Okay. Now homebound speed, why have we taken 215 now? Because that is a reduced task. We have considered that coming homebound, that is A to PNR and PNR to B. So when going from A to PNR, our engines are working normally. All engines are working. At PNR, we suffer an engine failure and we come back to point A. That was our origin. Okay, so that's why when coming back from point A, we will use reduced task. And that reduced task I have written. Next, put wind velocity 090 at 30, 090 at 30. So CX3 will be equal to 250 knots outbound speed, course 135, 30 at 90. So your ground speed will be 228 knots. 228 knots. Going homebound, your track is 315 and speed is 215. So 215, 315. So your ground speed now is 235 knots. 235 knots. So this is the table that we have done to calculate ground speed. Now whenever, remember this, whenever you have to solve PNR sum with an engine failure involved in that question, you will use the formula distance to PNR equals to upon gross fuel consumption. Flight fuel upon gross fuel consumption. Now what is gross fuel consumption? Gross fuel consumption is the fuel used to travel every 1 nautical mile. Let's say you have a total fuel in your fuel tanks of total fuel on board, let's say is 100 kg, and your gross fuel consumption is that you are you are using 1 kg of fuel every 1 nautical mile. You are using 1 kg of fuel every 1 nautical mile and you have total fuel 100 kg. So how many nautical miles will you travel? How far will you travel using all the available fuel, which is 100 kg of fuel? So distance will be in that case, if you're traveling 1 nautical mile with the help of 1 kg, so for 100 kg you will travel 100 nautical miles. 100 nautical miles. Okay. So this is how you calculate gross fuel consumption, or this is the idea of gross fuel consumption. Fuel use for every 1 nautical mile. Now to calculate this distance to PNR with the help of gross fuel consumption, we know flight fuel, which is fuel on board minus reserve fuel. Okay. Gross fuel consumption. Let's find gross fuel consumption. Gross fuel consumption, you have two types of flight. when going from A to PNR 1, and to PNR 1, then coming back from PNR to A, that is the second route of light. Okay, so the gross fuel consumption that you have to find out should be an addition of both this route of light. Okay, that is uh, route from A to PNR. So how much fuel was used every nautical mile when going from A to PNR? Okay, when all your engines were working, plus route PNR to A. So how much fuel was used when you came back from PNR to A after engine failure? So your fuel consumption rate will decrease, your TAS will decrease. So the formula is fuel consumption normal divided by ground speed, fuel consumption reduced divided by ground speed, homebound, this is outbound. So normal fuel consumption was 1200 pounds per hour. Outbound speed was outbound speed was 228. Homebound fuel consumption is 1000 and homebound speed is 235. So that gives us 5.2. 1000 divided by 235, 4.2. So that is equal to 9.4. So distance to PNR will be flight fuel divided by gross fuel consumption. So 9.4. So 10,000 divided by 9.4 is equal to 1063, 1063.8 or 1064, 1064 nautical miles. Approximately 1064 nautical miles. Okay. Time to PNR will be how much? Time to PNR will be equal to 1064 divided by outbound ground speed is how much? 228. So 228, which is 4 hours 40 minutes. 4 hours 40 minutes. Okay. So a different kind of sum. So let's begin a quick recap. We started with critical point. Critical point, nothing new, just the same data table. Substitute the values in the formula. Calculation of PNR under normal circumstances, same. A table and the formula only. You have to remember whether it is normal circumstances, then you will use the same task, that is normal task. And if it is engine failure for critical point, yes. If there is engine failure mentioned in the question, like they have given two different tasks, then you will use that reduced task for return journey after critical point. Then they asked us to calculate still a range, the simplest of all. And when you have been asked to calculate PNR on three engines, okay, after engine failure, we will draw a fresh table, okay, where you will include a reduced task, okay, and then you will use this formula, which is distance to PNR equals to distance to PNR equals to distance to PNR equals to flight fuel divided by gross fuel consumption. What is gross fuel consumption? The amount of fuel that you will require or that you use to cover every 1 nautical mile. So we saw an example. If you require fuel on board is 100 kg and your gross fuel consumption is 1 kilogram every nautical mile, so the total distance you will cover will be 100 nautical mile. So to cover 1 nautical mile, you are taking 1 kg. For 100 nautical mile, you will require 100 kg. So how to calculate gross fuel consumption? You will be adding two elements. First going A to PNR and then PNR back to A. So formula is fuel consumption. When you go from A to PNR, everything is normal. Coming back, everything will be reduced. So you add that and you will get 9.4. Then substitute in the formula. 10,000 divided by 9.4 is 1064 miles. Time will be distance divided by outbound speed, which is 4 hour 40 minutes. In the exam, you have to do this like this and select the closest option.